Alright, welcome. In this video we're going to be talking about the geometry of parabolas. And so one thing I haven't told you about a parabola yet is that a parabola consists of all the points that are equidistant from a certain point in a certain line. And so we're going to call that point the focus point and that line the directrix. And I've got this diagram for you that I kind of want you to mark up and label for yourself. Now the first thing I want you to notice is the equal distance property. So if you just pick a point on the parabola, kind of at random, but or like maybe there, and you draw a straight line from that point to the red point, and then drew a line from the gray point to the blue line, and then measured, you'd find that they were the same length. And I think that was what we did in geometry to denote that those were congruent line segments. And so I'm gonna, past this, I'm not gonna say much about the equal distance property. But I am going to label the point as the focus and the line as the directrix. And the really key fact here today is about the distance from the focus to the vertex and from the vertex to the directrix. Now, if we call that distance P, that distance from the vertex to the focus and the vertex back to the directrix, which has to be the same, right? If we call it P, then that a in the original formula, that leading coefficient, number that's multiplied by x squared, that's going to be given by 1 over 4p. Okay, so that's the really important fact for us in this lesson today. That's going to help us solve the problems. Now, if you're wondering why is that the case, why is a equal to 1 over 4p? On the next page of your notes book, if you've got my notes, then you're going to see why. Okay, I went in and there's quite a bit more explanation in algebra below this, but it has to do with the equal distance property. Okay, so if you went in and you did the distance formula from 0p to xy, and then the distance formula to xy to x and negative p, and set those equal to each other, you would get the equation y equals 1 over 4p multiplied by x squared. And if you need more on that, I'll say come talk to me about it, but I don't think that that's going to be the best use of our time here together today in this video. What I do think would be useful in this video is working some examples, finding some focus points, finding some equations of directrix lines, and just showing you how to solve these problems that you're going to have to face on the quiz and on the test. In my class, I'm never going to ask you to prove the a equals 1 over 4p formula. That's just not the level we're at. So, but where we are at is find the equation of the directrix, find the coordinates of the focus point, find the coordinates of the vertex. So I'm going to start off with number 1, and I think I'm going to work both of these for you. So number 1 is y equals 1 over 4 times x plus 2 squared plus 3. Now I'm looking at a couple of equations in vertex form, and so I just want to remind you that if I'm looking at an equation like that, the vertex is at h and k. Okay. So in this case, on both of these, I'm just going to start with a vertex. On number 1, the vertex of this parabola is going to come where x is negative 2 and y is 3. Okay. And I know it's going to open up because of that 1/4 of x squared. Okay, so there's a sketch. It doesn't have to be perfect. It just, it needs to be opening the correct direction. That's what's important. And now I know that the focus point is going to be up here above the vertex because, we saw in the diagram that the focus is on the inside of the parabola. Okay, the parabola curves around the focus point is another way to say that. So I know it's going to be up above, and the directrix is going to be down below, similar distance. But I got to figure out what that distance is. So I'm going to grab this 1/4 number, and I'm going to use a equals 1 over 4p. Okay, so I know that a equals 1 over 4p, and a is equal to 1/4, so 1/4 equals 1 over 4p. Looking at that equation, I can see that p is going to need to equal 1. Okay, so that means I need to go up by 1 and down by 1 to get to the focus and to the directrix. So if I go up by 1 from the vertex, which is at negative 2 and 3, the focus point will be at negative 2 and 4, right? Because it's just 1 unit higher and wide, same x. So focus is going to be negative 2 and 4. And then my directrix, well, it'll be 1 unit below the point negative 2 and 3. So it's 1 unit down that way. And so that point right below negative 2 and 3 would be negative 2 and 2. Okay, but it's a horizontal line. It's the set of all points where y is equal to 2. So I'm going to say my directrix is y equals 2. Okay. I'm going to need to make this a little smaller so I can fit in my room for the second one, or my work for the second one. Okay, for the second one, I'm going to take the same approach. I'm going to start with a vertex. Okay, that's going to be where x is 1 and y is 2. Okay, I know that this one's going to open down because of the negative 1/16 of x squared. It's going to be really wide because of the negative 1/16, but I'm not that concerned about it because this is just a sketch, right? Okay, so that's going to be good enough for me. So that's my vertex right here. Okay, the focus point is going to be down here inside the parabola. Okay, and then the directrix will be a similar distance up above the vertex. Okay, and okay, now I need to figure out what's going to be the distance from the vertex to the focus and the vertex to the directrix. So I'm going to do the exact same thing. I'm going to take this negative 1/16, and I'm going to use a equals 1/4p. So since a equals 1/4p, I know that I'm going to need negative 1/16 to equal 1/4p. Okay. And, you could cross multiply to solve this, or you could look at it and say, oh, I think p is going to need to be negative 4. Either way, you're going to get p equals negative 4 if you solve this one correctly. Okay, and, you could look at that as saying, like, oh, okay, to go from the vertex to the focus, I need to go down by 4 because p is negative, but I think it's safer to think about the direction the parabola opens and understanding that the focus is on the inside of the parabola. I think that's the way to go, personally. But either way, I'm going to have to go up by 4 to get to the directrix and down by 4 to get to the focus. Okay. And if the vertex is at 1 and 2, and I go up by 4 to get to the directrix, well, that'll be the point 1 and 6, but the directrix is the set of all points with that y-coordinate, so that'll be the set of all points where y equals 6. Okay. And then the focus, I need to go down by 4 from the point where x is 1 and y is 2. So if I go down by 4, I'm going to subtract 4 from y, and I'll have x is 1 and y is negative 2. And I think I'll work this third one, but then I will let you try it on your own on the 4th, 5th, and 6th examples. So again, I'm going to start by identifying the vertex, which in this case is going to be where x is negative 4 and y is negative 5. Okay, this one's going to open up because of the leading coefficient of 2, because that's a positive number. So I'm going to just kind of draw my sketch, label my vertex, which is negative 4 and negative 5. Okay, I know that the focus point is going to be up here a little bit, and the directrix will be a similar distance below. Okay, that doesn't look that close. Maybe I can just try once to move that up, and maybe that'll be a little closer to equal. Okay. Next order of business is to figure out the distance from the vertex to the focus. So I know that a equals 1/4p. So that a is 2. So 2 equals 1/4p. And, if you're having trouble seeing it, you could write 2/1 equals 1/4p and do a little bit of cross multiplication. I'd have 8p equals 1 times 1, which is 1. I could divide both sides by 8, and I get p equals 1/8. I can already tell I'm going to need some more room here. And so I'm going to go up by 1/8 to get to the focus and down by 1/8 to get to the directrix. So that's my focus point and that's my directrix line. Okay, so the coordinates of the focus. Okay, x is going to be the same. I'm only going up. I'm not going left or right, so x will still be negative 4. But y will be negative 5 plus 1/8. Okay, so if you want to write that as a decimal, that's fine. I'm going to write it as a fraction, though. So in terms of eighths, negative 5 is negative 40 divided by 8. So if I had negative 40, but I added 1, I'd have negative 39. Okay, so negative 48 plus 1/8 is negative 39/8. And then the directrix line It's a horizontal line, so its equation is gonna start with a y equals. But the vertex is at -5. The directrix is 1/8 below that, so it'd be -5 and an eighth. Okay, you could call it -5.125 if you wanted. I'm gonna really try to encourage you to not use a mixed number because we need to be moving beyond those. But I'm going to write this as fraction, so -40/8 minus another 8 to go down by an eighth is going to be -41/8. Okay, and that's good, but again, still not nearly enough room to work the other example. All right, now I think you should try to work number 4 on your own. This is one where, okay, the vertex is going to be an 8 and 0. And if you want to try this one on your own and then just check your work against mine, then you're going to need to work with the video paused, right? Because the answer is just going to pop up here in a second. So pause now. Okay, there it is. So I started with the vertex. That's the point where x is 8 and y is 0. I sketched an upward-facing parabola, put in a focus and a directrix, and then I computed what is going to be p, what's going to be the distance from the vertex to the focus. Okay, I found that p was going to be 1/4 because the leading coefficient was 1. And then I needed to go up by 1/4 to get to the vertex, so that's why I added 1/4 to the x-coordinate of the vertex to get to the focus. I may have said that wrong. Okay, the focus is going to be 1/4 above the vertex, and the directrix will be 1/4 below the vertex, and so that, since the vertex had y-coordinate 0, the directrix will be the set of all points where y is equal to -1/4. Okay, let's try it again. All right, so here's 2 more for you to try on your own. Okay, I think these will be a good collection of 2. Again, you're going to need to work this after having paused the video because the answer is just going to pop up in a few seconds. So I would encourage you to pause now. All right, there you go. So I find my vertex points. Oh no, I didn't write the v. Or maybe I did and got lost along the way. But I found the vertex, sketched the parabola, determined the distance from the vertex to the focus, and then go up by that amount and down by that amount to get my directrix and focus. Okay. All right, let's move on. Let's do some backwards questions where we're going to look at a picture of the graph and write the equation. All right, so here's one where they're going to show us a picture of the focus and the directrix and the parabola. So we should really be able to see what the value of p is, right? I'm going to just enlarge this a little bit. I might need to remove it eventually, but let's start with, I think, with the value of p. Okay, so I know I went down by 1 from the vertex to get to the focus, so that's going to be p equals 1. Notice that you also go up by 1 to get from the vertex to the directrix, so that's just more evidence that p is equal to 1. Okay, and I know that the vertex form of an equation for a quadratic is y equals a times x minus h squared plus k. And so I'm thinking I might just kind of like fill in the ingredients. Okay, so if over here I've got the vertex point, and that's where x is 2 and y is 5. Okay, then I can go and I can plug in on h and k, right? I can say that, all right, h is going to be 2 and k is going to be 5. Okay. Now I also know that a is equal to 1/4p, and we just determined that p was 1, so I'm going to have a is equal to 1/4. So I can make that substitution as well. And now I've kind of like put in all my ingredients, I'm ready to go, right? That's a vertex form equation for that parabola. If I want to write this in standard form, then I'm going to have to, distribute the x minus 2 times x minus 2, and then I guess multiply all of that by 1/4, and then add 5 and get ax squared plus bx plus c. Okay, in order to do that, I need to first kind of like deal with this x minus 2 squared. So I'm going to go over here off to the side, kind of, and I'm going to say x minus 2 squared is going to be equal to, and I'll leave some room to do the work. Okay. I'm going to use the box method. X minus 2 times x and minus 2, so that would be an x squared, negative 2x, and positive 4. Okay, so x minus 2 squared is going to add all that stuff together, x squared minus 2x plus 4. Okay, so if I want my standard form equation, I'm going to have y equals 1/4 of, oh no, I lost a number there. x squared minus 4x plus 4. And then I'm going to add 5 after. Okay, so I'm going to distribute that. And, oh man, I made the same mistake again. I've done this so many times today. I forgot that it was going to open down because it's or that it's going to be negative 1/4 because the parabola opens down. Okay, yeah, we see that right there. And that won't change too much though. It's just going to change this, and but had I gone any farther, they would have been bad. Okay, so I'm going to distribute the 1/4 to the x squared, to the negative 4x, and the positive 4, right? So I'm going to say y equals negative 1/4 x squared plus 1x minus 1, because a fourth of 4 is 1, plus 5. And I've got y equals negative 1/4 of x squared plus x plus 4. And a good way to check would be on the y-intercept level. We know that the value of c in ax squared plus bx plus c has to correspond to the y-intercept. Okay, and I'm seeing a y-intercept of 4 on the graph. I'm seeing a y-intercept of 4 in the equation. So I'm feeling good about this. Alright, one like this where it doesn't come with a picture of the graph, it just is, a bunch of words, write an equation for the parabola with focus point here and vertex point there. You want to draw a picture. So I'm going to start with that. Okay, I'm going to start with the vertex, that's 3 and 4. Okay. 3 and 4.5 is going to be the focus point, so I'm just going to kind of label that with an F. And that's above the vertex, so I know that means the parabola has to open up. And then the directrix will be down here. Is that, well, they didn't ask for the directrix, but I'll probably just show you how to find it, right? So I see if I went up, the focus point is, focus point 3 and 4.5. And I went up by 0.5 to get to the focus, then I'll go down by 0.5 to get to the directrix. And this directrix, that'll be y equals 4 minus a half is 3.5. Okay, that's not what they're asking for. That's not going to help us write an equation for the parabola, but I'm just, what if they gave you the focus point and the vertex point and asked you to find the directrix, right? And I want to train you on that as well. Okay, so I'm going to go over here and write an equation. Well, if I can choose what type of equation I'm going to write, I'm going to use vertex form. So I know that I'm going y equals a times x minus h squared plus k. I know that a equals 1 over 4p, and p is equal to 0.5. Okay, so I don't really know where to put this. Maybe I'll go over here. 1 over 4p. P is 0.5, a equals 1 over 4 times 0.5, half of 4 is 2, so a is going to be a half. So I go and I fill that in. Okay, and then the vertex is at 3 and 4, so I'm just going to replace h and k with 3 and 4. And then that's going to be an equation for the parabola. And I think I'm not going to distribute this out and write it in standard form because I just did that in the previous example. Okay, this one's pretty similar, except it's going to give us the focus point and the directrix. And I think we'll need to, figure out the vertex. So if the focus point is at 5 and 2, and the directrix is y equals 8, okay, y equals 8 is above y equals 2, so I'm just going to kind of draw that here. Okay, so if this is the directrix and that's the focus, I know that the vertex needs to be halfway in between. And I'm just going to give myself a little bit more room to draw a vertex. That's a not very horizontal line, but it's okay. Right? We're not that concerned. Vertex is going to be halfway in between. Okay, so if this is y equals 8, and that's y equals 2, the y-coordinate of the vertex is going to be halfway between 2 and 8. We could average 2 and 8. We could say 2 plus 8 is 10, divided by 2 is 5. Now the x-coordinate is going to remain 5 because I'm just going straight up from the focus to get to the vertex, so it'll be 5 and 5. So I've got my vertex. To let it open down because it's going to curve around the focus point. And so I've got my vertex at 5 and 5. Okay. I know that it's y equals a times x minus h squared plus k. Okay, that's the vertex form of a quadratic equation. I need to figure out what's the distance from the focus to the directrix and the focus to the vertex to the directrix and vertex to focus. And it looks like it's going to be 3. Yeah, 3 on each. And so I know that, okay, a is 1 over 4p. P is 3. So a is going to be 1 over 4 times 3, which is 12. Okay, I think that happened. Okay, h and k are going to be 5 and 5 because those are the coordinates of my vertex. Okay. And that's an equation. Okay, if you were asked to write the standard form equation, again, you would need to distribute the x minus 5 times x minus 5. Okay, so I'm going to do that kind of off to the side. And I'll just do it for you since we're here. I'm already over 20 minutes. So this is going to be x minus 5 times x and minus 5. That'd be x squared minus 5x, another minus 5x, and plus 25. So x squared, add those two together, that'd be negative 10x and positive 25. So, oh yeah, still visible to you. Okay, so I've got y equaling 1/12 of x squared minus 10x plus 25. And then add 5. Okay. Alright, so I'm going to distribute the 1/12 over all of the stuff in red, so I'll have 1/12 of x squared minus 10/12, which is 5 over 6x, plus 25/12 plus 5. Well, in terms of 12ths, 5 is going to be 60 over 12. So I'd have 85/12. Okay, and then my standard form equation would be 1/12 of x squared minus 5/6 of x plus 85 over 12. Alright, now I got one more example for you. You might have thought I was done. You might have thought I reached the end of my notes and it's going to be the end of the video. But I've got a little something else for you that I think might help you down the road. Okay, so I want you to find the distance from the vertex to the directrix on this parabola, y equals 19 over 48x squared. Okay, so this is going all the way back to the first thing I told you about, a equals 1 over 4p, that leading coefficient. Okay, remember that p is the distance, so distance from vertex to directrix, that's like find p. And we've got a formula for p. A equals 1 over 4p. Okay. And okay, now I've got a equals 19 over 48. And that's going to be important. Now I'm going to cross multiply, but if you know what 19 times 4 is good for you. Okay, I'm going to play it safe because I know that that's the type of thing I might make an error on. So I'm going to say, all right, I'm going to go over here and I'm going to say 19 times 4p equals 48 times 1. Okay, and while I don't know what 19 times 4 is, I do know what 48 divided by 4 is. That's going to be 12. Okay, so I'm going to go over here and I'm going to divide both sides of this equation by 4. So I'll be left with 19p equals 12. Okay, so this is me keeping the arithmetic easy on myself when I don't have access to a calculator, right? And then I'm going to solve for p by dividing both sides by 19, and I would get p equals 12 divided by 19. So that's the distance from the vertex to the directrix, is 12/19. Okay, so I just wouldn't want you to see a weird multiple choice question like this with strange numbers and not know what to do, when in fact it's just a cross multiplication algebra problem. All right, I think that's going to be all the examples for this video. If you need more practice, you should start in on the homework. I've got solutions to that available as well. Lots of examples. So thanks for watching. Hope this helped.